Hello my dear student, how are you today? I hope all of you are well. So today I am going to start Taylor principle of gauging. Basically here we are going to design a gauge, right here we are going to design a gauge which are going to measure our workpiece, okay, whether they are under tolerance or not, whether they are out of tolerance, okay. So these gauging instrument basically decide whether we have to accept the product or reject the product. Okay, as I told you, suppose that, suppose that I will take an example. Again, I will take an example. My dear student, there is a shaft. Let's say there is a shaft. Okay, there is a shaft. Just a minute. There is a shaft, okay, of size, right? There is a shaft of size 30, let's say, plus 0.1 and plus 0.3, okay, mm, right? And this is the dimension of the shaft, and how much unit we have to produce? We have to produce 1000 unit. We have to produce 1000 unit. Similarly, suppose that there is a hole, right? There is a hole, got it? There is a hole, let's say, whose size is, let's say, 25 minus 0.1 plus 0.2, okay, mm. And the number of unit which we have to produce is what? We have to produce 1000 units, okay. 1000 units we have to produce, right? 1000 unit we have to produce, got it? 1000 unit we have to produce. Now, how can we decide how many units are going to be, perfect? Are you going to measure each unit with the help of a scale? Are you going to measure each unit with the help of vernier caliper? It is not possible, my dear. It is not possible, right? So what to do? According to the shaft, we will design a gauge for that dimension only. For that dimension only. Okay, that gauge is dedicated to that dimension only, and it will check the 1000 unit. According to the hole, we will design a gauge, and that dimension is going to be checked, okay, for 1000 unit, and that gauge is dedicated to only that dimension only, right? After that it will not work useful for us, because after that we have to manufacture a different size. So according to the product, we are going to design a gauge, okay, we are going to manufacture a gauge, and by using that gauge we are going to measure the product, whether they are lie in the tolerance or lie out of the tolerance, right? Now the next thing is, for a shaft, which gauge we use, my dear? For a shaft we use ring or snap gauges, right? Or you can say ring gauges. Simply you can say we should use ring gauges, okay, we should use ring gauges, clear? Ring gauges, right? Ring gauges. We should use what? Ring gauges, my dear student, clear? So that ring gauges, what they do, basically that ring gauges are going to measure the dimension. Yes, that ring gauge measure the maximum size of shaft, and that ring will measure the minimum size of the shaft. I mean, there will be a two ring. See, there will be a two ring of larger size or a smaller size. So my dear student, there will be a two ring, right? There will be a two ring. Let me draw here so that you can understand. Okay, let me draw here. These are my reference. These are for only reference, right? So this is a ring, okay. Again, see here, this is the next ring, right? Here there will be a solid material, here there will be a solid material, right? So this is a ring, you can see, this is a ring. So that ring, basically you can see a large size of ring is there. So that ring basically measure the maximum size of the shaft, right? That ring will measure the maximum size of the shaft, and we called as it is a go ring. It is a go ring. That ring will measure the minimum size of the shaft, that is 30.1, okay, 30.1. So it called as a not go ring. I will tell you, not go ring, okay. Right. Now, how can we measure the hole? For hole, we design a plug gauges. See, this is a plug gauge, right? Plug gauge. We design a plug gauge, right? We design a plug gauge. We design plug gauge, right? We design plug gauge. Plug gauge is what? Basically, it will be look like. Let me draw here. Let me draw here, okay, let me draw here, look, this is a plug gauge. Actually, this called as, okay, this plug gauge basically is going to be what? Check the hole. Are you getting my point? This plug gauge will check the hole, okay, one of them is go and one of them is what? Not go. See here. One of them is go and other is what? Not go. So the here smaller one is what? Here the smaller one is go, right? Here the smaller one is go and the bigger size is what? Not go. I will tell you why we call go or not go. Actually, these gauges are designed according to the Taylor's principle. Yes, Taylor's principle. These gauges are designed according to the Taylor principle of gauging system. How? Taylor says that you have to design go part either for ring or either for plug. See, here go is present in plug gauge and go is also present in ring gauge. So Taylor says that you have to design go in such a way so that it should cover the maximum material of the product. Am I clear? Maximum material of the product. Let me write down how should we design the go gauge. Let me write down here. Write down here. Okay. Let me write down here, and here I will talk about what? First of all, let's say I will talk about go. Okay, I will talk about go. Now what Taylor says that you have to design go in such a manner so that it should cover the maximum material of the product. Now, suppose that if you are talking that your product is what? Let's say a hole. Okay, let's say hole. If you are talking about, if you are talking that, sir, my product is what here? Hole. Okay, tell me, in which part of the hole, in which size of the hole material is maximum? Tell me. In which size of the hole material is maximum? Tell me. Tell me. In this size, na 25 minus 0.1. 25 minus 0.1. It has the minimum size, right? Let me take my calculator. Let me bring my calculator. Yes. Yes. In which size of the hole the material is maximum? If you are still not if you are still not able to imagine, then let me draw. Let me draw the hole. Okay. Let me draw the hole for you people so that you can visualize the thing, my dear. Okay, you can visualize the thing. Otherwise, what happen? You will not able to understand, right? You will not able to understand. Now, here, let me draw. Look, not this. Yes. See here. This is the minimum size of the hole. This is the maximum size of the hole. Are you getting my point? This is the minimum size of the hole. That is what? This one. 25 minus 0.1. So how much? 24.9, right? 24.9. It is what, my dear student? It is 24.9, right? 24.9. So it is a minimum size, and see here, the material is maximum now. See here, the material is maximum. See, the material is maximum. And it is what? It is a maximum size of the hole. See, maximum size of the hole. And what is the size? 25.2. 25.2. 25.2. Here you can see the size is what? Here you can see the size. Look, sorry. Here you can see in this size, the material is what? The material is what? Minimum. So what Taylor says you have to design go in such a manner so that it should cover the maximum material condition, right? I will write the condition so you will never forget in your life, my dear. You will never forget in your life, right? You will never forget. Taylor says you have to design go, okay, in such a manner it should cover, in short, it should cover maximum material condition. Maximum material of product, maximum material of, my dear, product. Am I clear? Maximum material of product. So here, if you are designing a gauge, plug gauge, for what? For a hole. This is a hole. This is your product. This is a hole. So for a hole, you have to design a plug gauge. So here, this is a maximum material. So according to this size, the go will be designed. That's why you have seen that the go part is what? Is smaller in a plug gauge. Got it? Smaller. Am I clear? So my dear, here, if you talk about what? Let's say, okay, now are you getting my point now? Now let me introduce about the not go. What is the meaning of not go? Now Taylor says that whether you want to make not go gauge for plug gauge or ring gauge, okay, you have to cover minimum material of the product. Okay, not go should be designed in such a manner so that it should cover, okay, listen me carefully, so that it should cover minimum material of product, right, of product. Now see, suppose if your product is whole, again, so where is the minimum material? In 25.2, right? So here you can see minimum material is there. So my dear student, not go. Here you can see, that's why the plug gauge not go size is what? Larger. Am I clear? I hope plug gauge is clear. Now I will tell you ring gauge. Don't worry, I will tell you the ring gauge, my dear. Right. Now what I told you? What I told you about the go. How should you design the go? Go should be designed in such a manner so that it should cover the maximum material of the product. My dear student, tell me, here we have discussed the whole now. Now I will discuss about what? I will discuss about shaft. Right, I will discuss about shaft. Suppose this is my shaft product and the dimension is what? 30, okay, 30. Yes, see, two shaft can be possible, as you know, two dimension can be possible. This is the shaft. Look, this is a shaft. Now, one of them dimension is what? 30.3, right? 30.3. Look, 30.3. And one of them dimension is what? 30.1. Am I right? Yes, 30.1. Clear? 30.1. Now, where is the maximum material? Here. So, for shaft, what gauge you produces? Ring gauge. So, a large ring, a go ring is designed according to that, because go gauge should be designed in such a manner so that it should cover the maximum material of the product. So, that's why, my dear, here I am going to produce, I am going to manufacture a ring, right? Here I am going to manufacture a ring, okay? Here I am going to manufacture a ring, sorry, here let me draw the ring here. I am going to manufacture a ring, okay, which cover the maximum material. So this ring will cover this much material. So that's why it is a go ring. Right? Now you have to manufacture a ring for not go in such a manner so that it should cover a minimum material. Minimum material is 30.1. So not go ring should cover the minimum material, my dear. See, not go ring it is what? It is, my dear, not go ring, right? It is what, my dear? Not go ring, right? It is what, my dear? It is not go ring. Clear? And it is go ring. Am I clear? Am I clear? Now this is according to the product. You have seen the ring gauge. Now according to the product of whole, I will draw the plug gauge also, so the concept will be clear to you people. Now this is a plug gauge I am drawing. Now what the according to Taylor, you have to design go such that it should cover the maximum material. Here maximum material is where? There, here. So this will be the go part of the plug gauge. This will be the go part of the plug gauge. Okay, actually the design, the dimension of go is selected according to this. Okay, now not go should be cover the minimum material of the product. Here the minimum material is there, right? So here I am drawing the not go gauge. See, I am drawing a not go gauge according to this. So my dear, it is what? It is not go. So not go dimension is according to this dimension. Clear? I hope my point is crystal clear to you people, right? My point is crystal clear to you people. This is a thing, my dear, very simple. Now here I am showing you an example. So by this example the concept will be crystal clear, right? The concept will be crystal clear. Suppose that, I hope it is visible to you people. Okay, yes. Suppose that it is given to you okay, it is given to you, suppose that a product is there, product is whole, okay, and the whole dimension is given 25 plus minus 0.2, right? 25 plus minus 0.2, and 1000 unit you have to be produce, 1000 unit you have to check. So for whole, what gauge we use? Plug gauge. So you have to design the plug gauge. One thing is also there, the plug gauge is not going to the plug gauge is not given by God. It is not given by God. You are going to manufacture, my dear. If you are going to manufacture, means you will do little bit error. If you will do little bit error, then some size of the gauge will be vary. If size of the gauge will be vary, it means on a gauge tolerance will become, but that tolerance is very, very, very less. Please recall IT01, IT1, sorry, IT01, then IT0, then IT1. That tolerance height is very, very small, and that tolerance will be uses. That tolerance height will be uses for a gauge's purpose. I told you at that time, right? I told you that time. So my question is, how should I give the tolerance on the gauges? There are some standard procedure, and you have to just follow that standard procedure. Okay, you have to follow just standard procedure. So let me introduce a question, okay, which help you to understand the design of plug gauge, right? The design of plug gauge. Dear, I am solving a question. Basically it is an algorithm. You have to just follow this algorithm to solve any question which is based on, okay, on a plug gauge concept. Am I clear? Which is based on plug gauge concept. So let me introduce you a question in which you have to design a plug gauge. Now your product is what? Whole, and dimension is what? 25 plus minus 0.02 mm, right? Right? No problem. Okay. Now what to do? The first step, you have to write the upper limit of the product and lower limit of the product, because according to the upper limit or lower limit, the material will be decided now, where the material is maximum and where the material is minimum, and according to that material you will decide now your go end of the plug or not go end of the plug gauge, right? So your second step, your first step is write down upper and lower limit. So higher limit of the hole is 25.2 mm, lower limit of the hole is 24.98 mm. Clear? This is, my dear, your first step, right? This is, my dear, your first step. This is, my dear, your first step. Clear? This is, my dear, your first step. This is first step. Clear? This is first step. Now the second step. You have to find the tolerance which is present on the workpiece, right? So what will be the tolerance? As you know, either you can do higher limit, that is upper limit minus lower limit, or upper deviation minus lower deviation. You will get what? 0.04 mm. So this is the second step. You have to find the tolerance of the workpiece, right? Now, my dear, the question is, I will select the go according to what? According to the size of the hole. Go should be, go ring, go end of the plug gauge should be selected in such a manner so that it can cover maximum material of the product. Where will be the maximum material? My dear, in the lower limit of the hole, there will be a maximum material. So go will design according to this, means the basic dimension of the go, basic size of the go will be 24.98. Am I right? Now you have to design not go end of the plug gauge. Not go means according to the tailor, the not go should cover the minimum material of the product. Where will be the minimum material in the product? In 25.02, right? In 25.02. Am I clear or not? So, my dear, your basic size of not go is what? 25.02. But the question is, sir, you have decided the size, it is on the paper, but when I am going to produce practically, then there will be some variation, and that variation basically means, sir, tolerance. What should be the tolerance we have to take? My dear, you have to learn always. You have to learn always. Otherwise, examiner will give you in the question, what will be the tolerance on the gauges? Otherwise, by default, you learn. Okay. Otherwise, examiner will give you in the exam, what should be the tolerance you have to give on a gauges. So, here, the gauge tolerance, okay, practically in journal, gauge tolerance always 10% of work tolerance, and this is work tolerance 0.04. So 10% of work tolerance means what? 10% of 0.04 comes out 0.004 mm. Means this is a tolerance which comes on a plug gauge, right? Which comes on a go end of the plug gauge, or you can say on a not go end of the plug gauge. Am I clear? Am I clear? This is a concept, my dear. Now, so the dimension of the go, okay, the dimension of the go is what? Please see here. Please see here. As you know, for a go, the basic size is what? 24.98. So you have to simply write here 24.98. Right? You have to simply write 24.98. Now, below than 24.98 the size is not possible, because this is the minimum size of the product. So below that the size of the go will not possible. So my dear, lower deviation on the go end comes, lower deviation is 0.0. Now you have to give the tolerance 0.004 means in a upper deviation. If in the lower is 0.0 comes, means it gives the minimum size of the go. Then for the upper deviation, it comes from the upper deviation, it gives the maximum size. So you have to write plus 0.004 mm. Simple, very simple, right? No doubt. Now you have to design, you have to give the design of what? Not go gauge. Very simple. What is the basic size of, what is the higher limit of the hole? That is 25.02, and minimum material will exist here now. I will write here minimum material will exist. Minimum material. Minimum material, my dear. Here minimum material. Right, minimum material. And here maximum material. Here maximum material condition. Here maximum material condition. Am I clear? Am I clear? Let me draw you all. Let me draw for you also. See here. This is the hole. Look. See here. See here. Minimum material. And maximum material. This is basically a hole I am drawing for you people. Okay, hole. I am drawing a basically what? Hole. Hole. Okay, 25.02 and 24.98, right? So here you can see there will be the maximum material in the product and there will be the minimum material. Simple. There will be the minimum material. So that's why I have selected go with respect to this. Now not go should cover. Not go end of the plug gauge should be designed in such a manner so that it will cover the minimum material of product. Here the minimum material of product is there. So the basic size will be then 25.02. So this is what this is the basic size, my dear. This is the basic size, right? This is the basic size. Now this is the maximum size which is possible, and this is the minimum material which is possible. Okay, I mean this is the minimum material which is possible, and this is the maximum size which is possible. So my dear, it is a maximum size. You can say then it is what? It will be the maximum size of your not go gauge. So that's why the upper deviation is what? 0.00. Right? Upper deviation is what? 0.00. Now you have to give the tolerance. So in lower deviation, you have to give tolerance in negative 0.004. Okay, negative 0.004, so the tolerance will become 0.004. Right? So this is the size of not go and this is the size of what? Go. Now my dear, my one question is there. Suppose that if I am putting, okay, suppose that in that figure, it is obvious that how a worker should conduct an experiment. Suppose that this is a hole, this is a not gauges, right? What the worker will do? I mean, what is the meaning here? Go and not go. Go means if the plug gauge go will go into the hole, okay, and if in the same hole not go is not going, means the hole is okay. Put in the correct slot. Take another hole for inspection. Now put the go in. Go is going, and also not go is also going. Means it is a defective hole. Put in the defective slot. Take another hole. Put the plug gauge go end. Okay, go end of the plug gauge. Go is not going. If go is not going, then it is obvious that not go will also not go. It will it is not going to insert into the hole. Okay, I mean if any one of the rule is violating, is not following, then the hole is what? Defective. Simple. Right? Then the hole is what? The rejected hole or a defective hole. So, my dear, the question is that maximum time, which end of the plug gauge? My question is maximum time, which end of the plug gauge will enter into the hole? Go end. So if the go end will enter into the hole for maximum number of time, then what happen? the chances of wear will be more on go, because not go will not going to enter into the hole. It is rarely, if it will be go, then there is a less number of chances, okay, and if it will go in a less number less number, then there will be a less wear. So means more wear will be happen on a go, always in the same manner. Suppose that you are using this ring gauges, so which ring will go or which ring will cover the shaft for a maximum number of time? Go ring. In the same manner, if go ring will cover this, if go ring is going over the shaft, means the shaft is okay. If not go ring is not going over the shaft, means the shaft is then finally okay. Then you have to put that shaft in the correct slot. Now you are going to take another shaft. Now suppose go ring is not going, and not go is either not go or not go. If go ring is not going, then simple, the shaft is defected. Put in a defective slot. Now take another shaft. Check, go ring is also going and not go ring is also going. Shaft is defected. Put in the defective slot. Take another shaft. If go ring is going and not go ring is not going, it means the shaft is what? Perfect. Put in a correct slot. Right? So here what we have understood, that the maximum number of time go ring is going. So my dear, on go gauges, either for a ring or either for what? Plug, you have to give a wear allowance. Right, wear allowance, and that is what? That is the 5%. Wear allowance is what? Wear allowance is 5% of the work tolerance. Right? I will tell you how should you add. So wear allowance is, my dear, 5% of wear allowance is 5% of work tolerance. Okay, 5% of work tolerance. So 5% of work tolerance means 5% of 0.04, right? Because you know work tolerance is what? 0.04. Okay, so 5% of work tolerance is 0.002. My dear, is that clear? Is that clear? Got it? Now my dear, as you know, there will be a wear on a plug gauge. Okay, I am drawing again. Please take care. Okay, please pay attention. I am drawing again. This is the plug gauge of go, right? And this is a not go. Now my dear, if the go will go, okay, maximum number of time in a hole, then there will be a wear, then the go gauge will going to be smaller due to wear. So what we do, we are going to a 5% wear allowance, means we are going to make little bit larger. How much larger? By 0.02, by 0.002 mm. So I am going to add 0.002 in the basic size. That's it. The limits will be as it is. The limits will be as it is. You just have to add the wear on the basic size. So now the go will comes 24.982. Limits will as it is, not go is as it is. Simple. Okay, I hope you understand the concept. Okay, I hope you understand the concept. Now we will solve some question also, don't worry about that. A question is there in GATE 2004. Okay, in GATE 2004 there will be a question, and I will solve one more question. Don't worry. Today we are going to solve a good number of questions so that you can understand the concept. Now my dear, this is a question, simple. See here, what the question is saying, it came GATE 2004. It came in GATE 2004. What the question is saying? Question is simply saying that you have to produce go and not go plug gauges. Okay, gauge are to be designed for a hole. Okay, hole is what? I hope the dimension of the hole is visible. Hole is 20. Okay, dimension is, hole is 20 plus 0.05. Okay, plus 0.01. Right. Gauge tolerance can be taken as 10%. 10% of the whole tolerance. It is given that gauge tolerance, how much you have to take? Following ISO system of the gauge design, go and not go gauges will be respectively. Okay, here he is not considering, I think, wear allowance. Okay, here he is not considering the wear allowance, right? So let's say we will do the question step by step. Okay, I'm not going to do a question in the direct manner. I'm going to solve this question step by step. What you have to do, you have to find the, first of all, first step is what? Solution. First step is what? You have to find the upper limit and lower limit. So upper limit is what? Upper limit of the whole. This is a whole now. So upper limit is 20.05 mm. Right. Lower limit of the whole is what? 20.01 mm. Now tolerance of the workpiece. Okay. Tolerance, or I will write the work tolerance, otherwise you will confuse. Workpiece tolerance. Workpiece tolerance, we can write work tolerance. Work tolerance means workpiece tolerance. Workpiece tolerance. It is what, my dear? 0.04 mm. Now it is given that 10% of the whole 10% of the whole tolerance you have to take. So 10%. Gauge tolerance is what? Gauge tolerance. Gauge tolerance is 10%. Okay, 10% of how much? 10% of work tolerance, that is 0.04, right? This cancel. So this is 0.004 mm. Clear? Clear? I hope it is clear. Okay. So my dear student, here in the question wear allowance is not mentioned, so I will not take. Okay, I will not take. So here the go end of the plug, go end of what? Go end of the plug, go gauge or go gauge of the plug. So what will be the go gauge? You know, go should be selected in such a manner where, so that it can cover the maximum material. Where the maximum material is there? 20.01. 20.01. This is a minimum size. So plus 0.000 and plus how much? 0.004. Okay. Now not go gauge of the plug gauge. Not go gauge. Now the basic size is what? 20.05. 20.05. It is a maximum size, and in that side minimum material is exists. So there is no size which will be, I mean, you cannot produce a larger size, okay, beyond that 20.05. So I will add plus 0.000. Now minus 0. Right, minus 0.004. Okay, 4. Am I clear? So according to that, two size will becomes, one size is 20.05, okay, and 20.046 mm. Right. According to here, two size will be possible. 20.014, 20.01. So my dear, you have to tell 20.0, 20.014 and 20.046, right? Design go and no go gauge will be. So the answer is what? Answer is B. Right? Answer is what? Your answer is B. Clear? I hope you understand the concept. Okay. Now let me solve one question. Okay. I am directly taking this question from a book, and it's a very good book. You can refer this book. Okay, it's a very good book. That's a P.C. Sharma. The reference is P.C. Sharma, right? I am taking this question from P.C. Sharma, so you can directly take this question from the. Okay, you can refer this book. It's a very good book. Okay. First of all, it is easily available, okay, and the author of that book is from IIT Delhi, right? and he referred the naphthalene basically content, naphthalene content, and you know if the content comes from naphthalene, then the automatically the book become very good. Okay, a lot of people will thought that the book is boring, but book is not boring. It depend on you that how much dedication you give, right? How much dedication you give. Now, here the product is what? Here the product is, my dear, a shaft, right? I hope it is visible. A shaft 75 plus minus 0.02 mm. Diameter are to be checked by help of a go and not go snap, that is a ring gauge. Design the gauge sketch it and show its go size and not go size dimension. Assuming normal wear allowance, here we have to take the wear allowance also and gauge maker tolerance. Wear allowance is what? 5% of work tolerance. WT means work tolerance, and gauge maker tolerance is 10% of work tolerance. Now, you have to solve this question by step, my dear. Okay, there is no need to hurry. Once you become perfect, then you will solve the question directly. It's up to you. First of all, okay, the first step is write down the upper limit. Write down the upper limit. Upper limit is what? 75.0, okay, 2 mm, right? And the lower limit is what? 70, how much? 74.98 mm. Now, work tolerance, find out the work tolerance here. Work tolerance, you know how much? This minus this, okay, it will become 0.04 mm. Now, you know gauge maker tolerance, okay, gauge tolerance. How much gauge tolerance? 10% of work tolerance, 0.04, right? So, it will become 0.004. Now, wear allowance, you know what is wear allowance? Wear allowance is 5%, always it will be a 5% of work tolerance, and it is what? 0.04, right my dear? 0.04, so it will become 0.002 mm, right? 0.002 mm, clear? Now my dear, the next step is here you have to select the basic size for go, right? You have to select the basic size for go. So here you have to design the go ring, na? So go ring will be designed in such a manner so that it will cover the maximum material. Here it is a shaft, so maximum material will be in shaft. Maximum material will be in that size of 75.02, and minimum material is what? In 74.98. Minimum material will be in, okay, 74.98. Am I clear? So go ring will be designed for with respect to this. So the basic size of go ring is what? 75.02. Am I clear, my dear? Am I clear? Now, not go ring. I mean, I haven't given the wear allowance yet. Now, my dear, here if you put the ring again and again on a shaft, then what happens? The ring size increases, right? The ring size increases. Means you have to give wear allowance in such a manner so that the ring should be little bit smaller, which will compensate the wear allowance. So how much it will be a smaller wear allowance? Means 0.002, means here the basic size of the go minus 0.002. Am I clear? Minus 0.002 mm. So it will be the basic size, my dear. It will be the basic size. So it comes out 75.018 mm. Right? right? So here just I am removing here because I have to write the solution. Now, what will be the then not go basic size? Not go size of the not go. So not go will be designed in such a manner so that it should cover the minimum material. The minimum material will be in the minimum material in this shaft, that is 74.98. So the basic size will comes out 74.98, my dear. Right? Now you have to give the Now you have to give what? You have to give the tolerance. Now listen, my dear. Now for go. What is the basic size? Basic size will be 75.018. Right, this is the basic size. Right, now above the size of the go ring will not beyond that size because it will be the maximum size. So here plus 0.000 means you have to select upper deviation in such a manner so that it comes that size will comes a maximum size. Now you have to give that lower deviation in such a way so that the tolerance on the gauge will become 0.004. So it will become only when lower deviation will be minus 0.00004 minus 0.004. Right? Now not go ring. Now not go ring is the basic size is what? 74.98, my dear. It is the minimum size. So below that size is not possible. So you have to select lower deviation in such a manner so that the minimum size will become 74.98. So here minus 0.000 and upper deviation will select on not go ring in such a manner so that the gauge tolerance come 0.004. So here plus 0.004. Simple. Finish. Right? Simple. Finish. That's it. It's very easy. Okay, it's very easy. Right? It's very easy. So I have solved two type of question, okay, on two different concept. Clear? So I hope you understand the thing. Right, my dear? So if I solve all the question, then what you do? Okay. Otherwise, I can solve the question. I have no problem. I have a question of GATE 2013. There is a question. I will solve a question. Okay. Not to worry. There is a question of GATE 2013. Or let me see. I have a question. If I have a question, then I will select metrology. Yes, I have a question. Look, there is a question. Please read it carefully. What the question is saying. Cylindrical pin of 25, okay, dimension is given. I hope it is visible. In mm, diameter are electroplating. I mean here pin will be act as a shaft. It will be act as a shaft. So pin means pin is a product and product will be act as product will be pin and it will act as a shaft. You have to do a electroplating. Okay, mm diameter are electroplated in a shop. You have to do a electroplating on that size. Okay, plating thickness is what? 30 plus minus 2 microns. 30 plus minus 2 microns. Neglecting gauge tolerance. Okay, neglecting the gauge tolerance. The size of the go in mm to inspect the plated component is. You have to tell me the size of the go, my dear. Okay. Whatever be the question, you have to follow the same algorithm. Okay. Follow the same algorithm. First of all, write the upper limit. Upper limit is what? Upper limit of the shaft, that is 25.02 and lower limit of the shaft is 25.01. Right? Right? This is the lower limit. Now, where will be the maximum material? Here maximum material is there. Here maximum material. Right? Maximum material is there. So go will be select according to the maximum. Go will be designed in such a manner so that it will cover a maximum material of the product. So the go is selected according to this 25.02. Now, am I clear? Neglecting the Gauss tolerance means here there is no need to give 10% of the work tolerance. Am I clear? Here there is no need to give 10% of the work tolerance. Right? Now, I'm not going to solve this question. Yes, you have to solve, yeah. If I solve all the question, then what you do? Tell me. Tell me what you do. Here I will discuss. Here I will discuss only. Now, neglecting the gauge tolerance means you don't have to give the 10% of the workpiece you don't have to take the gauge tolerance means 10% of the workpiece tolerance. Very good. So there is no need to find the work tolerance. That's why I haven't find out the work tolerance. Work tolerance. Right. There is no need to find the work tolerance. No need. Now, electroplating. What to do? Find out the different plating thickness. Find out the different plating thickness means 32 micron and 28 micron, right? Okay, I mean the plating will be happen on a shaft radially. So the maximum thickness, please listen, maximum thickness, okay, of plating which is possible is what? 32 micron. Okay, so you will write 0.032 mm, but the plating will be done on a shaft radially, so you have to make it twice. So it will become 0.064 mm. Now, minimum thickness of plating is what? 28 micron, right? In mm it will become 0.028 mm. My dear, the plating will be done radially on a shaft, so you have to make it twice. So it will become how much? It will become 0.056 mm. Right? Am I clear or not? Tell me. Am I clear or not? Is that clear? Now, my dear, the size of the go gauge. You have to select the size of the go gauge. Okay, and select the maximum thickness. Simple. Select what? Select the maximum thickness. Are you getting my point? You have to select the maximum thickness. Is that clear? You have to select the maximum thickness. So, go 25.02 and the maximum thickness is what? The size of the go gauge in respect of the component. Okay. So, the maximum thickness is what? Maximum thickness is your 0.064. Add this one and you will get your what? You will get your what? Answer. Got it? Got the concept? So, try the questions. Okay, try the questions. Now, one more concept is there. There will be a tolerancing. Okay, there is a tolerancing, a concept of tolerancing. Let me complete the concept of tolerancing first. That's why I am giving that question for your homework. Although I have solved 90%. So, what is a tolerancing? Basically, tolerancing is in tolerancing what we do, a design engineer keep one section of the part blank. He is not giving, he is keeping blank without any tolerance, so that the production engineer can dump all the tolerance on that section, all the tolerance on that section, which become the most inaccurate dimension of the part. Okay, let me explain in this manner. Suppose that this is the basically initial product, and I have to make a shaft from that, and I have to make a shaft whose length and whose diameter is this. Okay, but what about this remaining part? Here, this remaining part is, my dear, see, this one is the remaining part. Oh my God, see here, this one is the remaining part, I mean unmachined part. This is what? This is unmachined part. Now, this is the dimension which I want to achieve. a desired length. Now suppose if I want to increase the length, then what I do? I will dump all the dimension on that undimensional part. This is a tolerance sink, right? And tolerance sink will be present and at any location, at the right side, at the left side, in the middle side. It will depend on the product. It will depend on the product. Clear? So that is about the tolerance sink. So the position of sink can be changing from the reference point. You can change it according to the reference point. Now there is a question of gate 2000, okay, gate 2003, and the question is pretty simple. Okay, question is pretty simple. I mean the question is based on, based on your aptitude. Based on your aptitude. See, just a minute. Yes. Arey Baba. Yes, see. A part shown in the figure is machined to the size given below. Okay, a part is given. See here, a part is given. This is a part. Okay, a part, basically the total dimension is P. If you decompose it, then it will be a Q, W and R. Okay, so P is 35 plus minus 0.08 mm, Q 12 plus minus 0.02 mm, R 13. Okay, here the dimension, I think it is visible to you. If not visible, I will write 13, okay, plus 0.04 minus 0.02 mm, right. Now, you have to tell me the dimension of W, okay, with W. Got it? You have to tell me the dimension of W. The concept is very simple. Look, the concept is very simple. I mean, here, I think the question is visible. I will write again if it is not visible. 35 plus minus 0.08 mm. Okay, 12 plus minus 0.02 mm. Clear? Now, you have to find the dimension of W. You know P is what? The concept is very simple. P is what? P is Q plus W plus R. What you have to find? W. So what is W? W is P minus Q plus R. Right? Q plus R. My dear, now the twist comes. You have to give me the two dimension of W, which I mean the upper limit and lower limit of W, means maximum size and minimum size of the W. So the W max will become, okay, the maximum of W will become when you take P of max minus, if you take Q plus R of what? Of minimum. Simple. Finish. That's it. That's it. Right. Now, what is the P max? You can see. What is a P max? Okay. P max is what? P max is 35 point. Again, I am not going to solve this question. Do the calculation by your own. 35.08 mm. Okay. Write P min also. Maybe later it will be required. Right? 35 minus 0.08. So P min is 34.92. In the same manner, what is the Q max? What is the Q max? Q max is 12.02. 12.02. What is the Q min? Q min 12 minus 0.02. Okay, it will become 11.98. Now, what is the R max? R max is, I hope it is visible. Yes, max and min. R max is what? 13.04. What is the R min? Okay, 13 minus 0.02. It will be 12.98. Right? I hope the concept is pretty clear. Okay, so just put the value. You have to do a plus minus. That's it. That's it. You have to do a plus minus. Okay, if you are not able to solve that thing also, I will solve from your side. P max is what? 35.08 minus Q plus R min. What is Q and R min? Q min is 11.98. What is R min? R min is 12.98. Simple. So 35.08 minus 11.98 plus 12.98, right? It comes 10.12 mm. So here W max will come 10.12. Now you have to find what? W min. So W min will becomes when you take P min and minus Q plus R max. Simple. So here P min is what? P min is 34.92 minus Q plus R. Q is what? Q is Q plus R max. Q max is what? 12.2. 12.02, sorry. Plus R is what? R max 13.04. So 34.92 minus 12.02 plus 13.04. 9.86 mm. Now from which option? See the option. I think the option is B. See, 9.99 plus minus 0.13. By this only this size and this size are coming. See, 9.99 plus 0.13. Yes, if you plus 9.99 plus 0.13, it comes 10.12, and 9.99 minus 0.13, 9.86. Yes, so the answer is, my dear, B. So I hope you understand the thing. So we will meet tomorrow and discuss the further thing. Thank you.